Alright, what's going on guys? Your everyday math tutor here, and in today's video we have a new setup. Hopefully this is, well actually it is much better than the last setup, because last setup I couldn't charge my iPad because I had to connect an external microphone to it, so it couldn't charge, so it would die pretty quickly because it was using that power to power the microphone too. Or using the battery to power the microphone. But now I have a USB-C cable connected to my MacBook. I downloaded OBS, and now we could see me have a better microphone that doesn't pick up everything, and we can see what I'm writing simultaneously. So in this video, we're just gonna do a continuation of the previous lesson, the previous video that we did, and that was derivatives. Now, um, just to give you guys a note, it's not it does not involve the product rule or quotient rule. That's gonna be next lesson. The next video I do will be on the product rule and quotient rule. Yes, I know we can use those rules in a couple of examples that we're gonna see here, but we're just gonna assume we don't know those rules yet. All right, so here we have our first example, and all we need to, and I don't know why I wrote equals, should write parentheses around these. So what we need to do here is just do a little bit of algebra and then take the derivative. So what we'll do here is take the derivative, or actually let's rewrite the first term as x to the power of negative half. We're just rewriting the radical as a fraction in the bottom, in the denominator for the first term, and then taking its inverse. And then for the second term, again, we're using the index to put into the denominator of the rational exponent. At least for this one, it will be 1/4. And now we can take the derivative of both of these terms. So that will look like this as follows. So we have x to the power of negative half, and then plus the derivative of x to the power of 1/4. I know, I get it. We don't have to actually write this part, but just so some of us could see it, what we're actually taking the derivative of. I get it. When we get used to it, we're not going to have to write this over and over and over again, or at least we can skip this step. But we'll take the derivative of the first term, and that's going to be negative half. We're using the power rule, remember that. And then times x, and then negative half minus 1. So we're going to have negative half minus 1, which is going to be negative 3/2. So that's going to be what's in the exponent for the first term. And then plus 1/4, always multiplying the exponent for the power rule here. And then times x, and now we're going to have 1/4 minus 1, which is going to be negative 3/4. So negative 3/4 is in the exponent for the second term. And this, ladies and gentlemen, is our final answer for this problem. All right, so what we need to do here is just distribute that x cubed into the two terms inside the parentheses. So we'll do that first before we take the derivative. So we'll have x cubed times x, which is x to the fourth power. And then we have x cubed times 3, which is just plus 3x cubed. And now we can take the derivative of both terms. The derivative of x to the fourth power is going to be 4x cubed. And then the derivative of 3x cubed is going to be 9x squared. And this is our final answer. All right, here's our next example. That is the derivative of 3 times e to the power of x plus 4x to the power of negative 1/3. We're going to need to take the derivative of both of these terms. And all right, so both of these are going to use the constant multiple rule. We'll just factor out the coefficients here. We have 3 times the derivative of e to the x plus factor out the 4, and then take the derivative of just x to the power of negative 1/3. Okay, so for the first term, we're going to have 3 times, and the derivative of e to the x is just going to be e to the x. And then 4 times the derivative of x to the power of negative 1/3. Of course, we're going to be multiplying that exponent and then subtracting negative 1/3 minus 1, which is going to be negative 4/3. So that's exactly what we'll have in the exponent, negative 4/3. And then all we need to do is really just multiply the 4 into the negative 1/3. So we're now going to have 3 to the power, 3 times e to the power of x plus, or actually it's not plus anymore, it's going to be minus now. So minus negative or minus 4 over 3x to the power of negative 4 thirds. And this, ladies and gentlemen, is our final answer for this particular problem. All right, so I thought it's probably a little bit important that we include another exponential derivative or another exponential function that we need to take the derivative of. And just to remind you guys what that rule looks like, let me change the colors here so I can color code it real quick. The rule is basically when we take the derivative of e, we're essentially rewriting the same function that we're given, but we're taking the derivative of the exponent. I'm going to write it as f of x in this case. So our derivative really has this, taking the derivative of that exponent, which I have here as f of x, and then just rewriting the original problem or the original function. And that's it. So let's do an example so we can better understand what that actually looks like. So we already know the answer is going to have this original function. So that's what we could write right away. So we're going to have 4e to the power of 4x squared plus x. And then all we need to do is take the derivative, I don't know why I wrote it so down below there, of 4x squared plus x. We're just taking the derivative of the exponent here. All right, so we're going to rewrite 4 times e to the power of 4x squared plus x, and then take the derivative of 4x squared, which is going to be 8x, and then take the derivative of x, which is just 1. And this, ladies and gentlemen, is our final answer. So essentially what you're doing, again, when you take the derivative of an exponential function, all you're doing is rewriting the problem or rewriting the function that's given, and then taking the derivative of the exponent. And that is it. It's literally that easy. Now again, in the next video, we're going to have the product and quotient rules, so stay tuned for that. If you guys enjoyed this new setup, please let me know. If you enjoyed the video, please give this video a like. If you want to see more videos like this, please subscribe to my channel. Hit that notification bell button down below to be notified when the next video is up, and I'll see you guys in the next one.